All right, guys. Everybody got your number 4 out? Let's take a look. Number 4, 5, and 6. And remember, our first multiple choice quiz starts tomorrow.
Calculator or no calculator?
That is the no calculator tomorrow. And then we'll do the calculator. And I know I put 25, 25. I may just do them 50 total since there's more points on the first one than the second one. So I know I put that there just because I wasn't really thinking. I'm just going to go a certain point total so that the total of the 40 whatever questions is 50 points. All right. Okey-doke. Number 4, it said, let f be the function given by that. All right. And it says, and remember, number 4 is a no calculator problem. It says, find the limit of the function as x approaches to infinity and to negative infinity. So what are you thinking to infinity?
Plug in infinity.
So you're kind of thinking, yeah, I'm thinking growth. Okay. So when I look at this, x squared is growing towards what? A parabola, as you move towards infinity is doing what as you go to the right? It's getting huge. What is an exponential function doing as it's going to the right? Also getting huge. What's a huge times a huge? Huger. Right? So got to be infinity there. All right? Is there a
Because infinity is the same thing.
Yeah, I know, but maybe they took that.
What is that?
What are you looking at?
There was a random white dog that just ran up the hill.
Oh shoot, that's what.
Okay, so infinity. I wrote D and E here. Maybe the key said if you put the limit does not exist, they gave you half that point for that as well. But we can do better than that by putting infinity. So anyway, now why is this one 0?
Because an exponent raised to a negative number is the same thing as like.
That's right. So if I think about a parabola going to the left, I'm still going to infinity on that parabola, right? So that's getting huge. But an exponential function flattens out to the left. So if I'm heading left on an exponential function, or like George said, if I plug a negative infinity there, e to the negative infinity is like 1 over e to the infinity, right? And if you think about it that way, the bottom exponential function would be growing faster than the top powered function. Does that make sense? And in that regard, this fraction would be shrinking towards 0. So you could think about it either way, but definitely no points for partial, for credit. I mean, for showing work or anything like that, just being right gave you a half a point each. So that was a 1-point question. Part B, it says, find the intervals on which the function is increasing. Show the analysis that leads to your answer. You get absolutely no credit for this, but I use that to help myself think. Okay, so the readers are instructed to literally cover that up. So if you don't explain your thinking when they say show the analysis, then you don't get your credit. Okay, so it's not just an answer. So right here, you got actually 2 of your 4 points for recognizing what to do if the function's increasing. So if a function's increasing, what do you know about it? The derivative of it would be positive. And to determine where it's positive, you would have to know where it's. Yes, but you have to find out where it's 0, what the zeros are, and then check in between them to see where it's positive or where it's negative. So the derivative is not too bad. First derivative of the second plus the second derivative of the first. Now, I need to set that equal to 0, but they gave you 2 points on this for just evaluating the derivative, which is pretty gracious, right? And then it looks like they give you a half a point for setting it equal to 0. It's normally not like that. Normally it's a point for the derivative, a point for setting it equal to 0, and then, but that's what they did. Now, how do I figure out how to solve that? So what I do is factor it, especially if there's an e to the x in there. Let's get that e to the x out of there So since each part had an e to the x, I pulled it out and then just added the other junk together, which conveniently ended up being pretty nice. Now, when I think about these two things and when they're equal to 0, what can you always do with that e to the x? Ignore it, because there's no way it's 0. It's constantly above the x-axis, never hits. So I don't even have to look at that in this analysis, right? But I do have to factor this, which actually doesn't factor, but you can solve, right? Set it equal to 0, square it both sides, and you get plus or minus root 3, which actually makes it easy on you, in my opinion, because by putting it there, it allows you to check with nice, neat whole numbers, right? So I just go in there and I check. So now that I know the critical numbers, I checked -2, because I know root 3 is about what? 1.7-ish, which is a good thing to know, and root 4 is about 1.4-ish. Because I know that I take -2, 0, and +2. Remember, I'm checking the derivative. Don't plug it in the function. So I'm plugging it back into the derivative. Do I even need to think about this? Again, no matter what I plug in there, what's this going to be?
A number.
A positive number, right? So I don't even have to worry about it. I know that part's positive, right? If I plug a -2 in there, though, I get 4 minus 3, which is positive. If I plug a 0 in there, I get 0 minus 3, which is negative, decreasing. And if I plug a 2 in there, I get 4 minus 3, which is positive, increasing. But no matter what I plug into the e function, e to any power is going to be a positive number. Even e to the -1,000,000, right? That just shrinks down to a really tiny positive number. So bottom line, I can see right here, it wants to know where it's increasing from -infinity to -3 and from 3 to infinity, right? And I just make the statement. How do I know that? Well, I know it increases because the first derivative is positive there. That's literally what you did when you did this, right? You were looking for the derivative was positive. So just say that, but you can't say this. Use it, but you can't say it. And you can write it. You don't have to cross it out when you're done. They're just instructed to cover these up. All right, so that's 4 points there. Hopefully we got a lot of those, or at least some of those. C, find the intervals on which the graph of f is concave down. Well, where is a function concave down? When its second derivative is negative. So if I already have the first derivative, I need to find the second derivative. Now, when I look at the second derivative, I can use this and go first d second plus second d first plus first d second plus second d first, and that might be better. Or I can use the simplified version. This is the first derivative, right? Now, the only risk you have on using this one is if you did it incorrectly, then that's going to snowball on you. Like if you did your factoring and you're simplifying incorrectly, well, then that one mistake's now going to become another mistake. So that's going to be up to you. If you feel really confident in your math, then use this one. I did, so I used it. But I also had a key to catch my errors before I presented it to you. You won't have that. So you make the call on that. I kind of like making my life a little bit easier and just be really careful getting to this point. But you have two options. So I went and used the e to the x squared minus 3. So first d second plus second d first. Again, they gave you 2 points for that, which again I thought was pretty generous. They only gave you a half a point for setting it equal to 0, which was a little ungenerous. Yes?
For the first d second, second d first, is it okay if we wrote that in a simplified way?
What do you mean simplified way?
Like, for that part, I just wrote x squared times e to the x plus 2x times e to the x minus 3 times e to the x.
Oh, you just distributed that out?
Yeah.
That's fine. Sure, yeah. I mean, ultimately, you're going to have to factor it anyway. So as long as you have a correct derivative in some form or fashion, you're okay. Okay, even if you use that unsimplified first derivative to do it, these readers are pretty smart. Like, they don't let anybody read a test who hasn't taught APCalc for at least 3 years. And most of the time, it's well beyond that. So they're not morons that are reading your tests. Now, they are reading them quickly, so I like to make it as easy as possible on them if I was a student. But anyway, bottom line, I get to this, or in your case, I have an e with each one. If you have an e with each one, it's even easier to see that you could factor that e out, right? And then you have that and that remaining. This factors nicely. And again, guys, label your work. Don't just do the second derivative and don't label it, okay? Make sure you're labeling it, although in this case, they just gave you 2 points for that. So in this case, I have it labeled. I have it set equal to 0. Do I have to worry about this when it comes to equaling 0 and finding solutions? I don't, because it's always positive. It's never 0. but these are 0 there and there. Mark them. And this time, I'm not doing increasing, decreasing, increasing. I'm doing concavity. Okay, but again, they aren't looking at that. So whatever you write there is not going to be right or wrong to them because they're not looking at it. So I'm checking the second derivative now. So I use -4, 0, and 2. And when I did that, I got a positive value here, which meant CCU, a negative value there. But again, I'm just plugging it into here to check the signs, right? Anybody got a question so far? So this tells me that it's concave down on the middle interval from -3 to 1. How do I state that? Literally, what did you conclude? Because the second derivative was negative from -3 to 1, I know it's concave down. That's literally what I'm saying. Because the second derivative is negative, and you can say is negative, but I like less than 0 is quicker, then I know on that interval, I know that the function is concave down. Also, if you wrote the word it in there, you've got to quit using it. It modifies something, but they don't know whether it's f, f prime, f double prime, integral of f. You can't use it anymore. Okay, just chuck it, whatever from your vocabulary and really be specific on which function or which degree of the function you're talking about. You tracking?
Right.
Okay, that's C, and that's 9 points. So to me, that's a relatively easy 9-point problem, which kind of offsets the brutality that some of you felt from the, the penguin problem in part 2, the rate of death rate or whatever, because a lot of people got beaten up on that. Some of you did very well on it, which is phenomenal. It's really great at this point in the game, especially considering we're more than a month out of just practice tests. I mean, think about that. It's a lot of improvement we're going to make. So, but this one to me was a relatively easier one, and you'll see that mixed in through the 6, typically. And if you think they're all easy, awesome. Number 5, it says the graph of the continuous function f is shown above here, and it consists of 3 line segments and a semicircle. Let g be the function given by this. What does that mean here? G is the what? The area under f from -2 to x. Now, before we had one that went from -2 to 5, but they said 0 to x. So be really careful on looking at that bottom number. That's really important. So I'm going from -2, right? Not from -6. So be careful about that. All right, first thing says find g of -6. So g of -6 is telling you to go what?
Backwards.
From -2 to -6, which is backwards. So I want the area from here to here. So if I'm going backwards, that area, which is normally positive, now becomes negative. And I'm just going to go base times height. So 4 times 5 times a half is 10, but I'm going to remember to make it negative, right?
Right.
That's 1 point, and you really just got 1 point for your answer there. The second part was find g of 3. So g of 3 would be just from -2 to 3. So now I'm going from here to there. So -2 to 2 is just a semicircle, right? So half of a pi r squared. And then this last part, which is positive because you're heading that way. And then the last part is base times height, which is 1 times 2 times a half. So that should give me a 1, but it's negative. So I get the 2 pi from this and the -1 from that, 2 pi minus 1. So to me, a little bit of work to do, but not too bad unless you made a careless error. And again, stop me at any point if you have questions on these. Part B, find g prime of 0. So if this is g, how do I find g prime? I take the derivative. So to take the derivative of the left side, I can dg dx it, or I can just say g prime. But to take the derivative of the right side, how do I ddx an integral? Second fundamental theorem, right? And what does the second fundamental theorem tell you to do?
Just distribute that x into it.
So ignore the integral, ignore the number, plug the x in, and then what?
Go from there. Get rid of the d2.
Multiply by the derivative of the x, which in this case is 1. But you need to remember that because they will sneak a 3x in there or a 4x in there. Always think times the derivative. Well, that just gives me this. So if I want to know what the derivative of a value is, what am I really, of g, what am I really doing? the function value on f. So if I want to know g prime of 0, I'm really just finding what? F of 0. And if I look at the f function at 0, it has a height of 2. So the value there would be 2. And you got 1 point for doing that, getting that answer. So the work for them on this case was not worth anything, but very often it is. So get in the habit of, and again, you don't know what you're getting credit for. They don't label anything. They usually go back and they go, all right, we need a certain average score in the country. So let's manipulate our scoring system to kind of get that. And they're not consistent in that regard. But on something like this, maybe they are. I don't know, whatever. C, for all values of x on the open interval from -6 to 3, for which the graph of g has a find all of them for where the graph of g has a horizontal tangent. All right, so first question, where would a function g have a horizontal tangent line? Where the slope of g is 0. And what is the slope of g? The slope of g is the f function, right? We just concluded that. So if I want to know where the slope of g is 0, I want to know where f is 0, right? So that's the first thing I needed to conclude. So where is the function? Where does it have a 0 value?
-6, -2.
-6, -2, and 2. So initially I'm saying that. And then I go back and I look at the question and it says, ooh, open interval. So I can't use the -6, but I can use the -2 and the 2. Yes.
If you, for this one on assigning points, if you just had -2 and 2 in your answers, would you get those 2 half points, or did you need to label it as f of x equals 0 at?
On this one, they gave you a half a point for each value.
But you just had to like have those 2 values on your paper.
Right.
All right.
Yeah. I mean, I label everything. I would say at f equals 0, at f of x equals 0, my x values would be -2 and 2. I'm going to say this. I'm going to make that statement because, again, I don't know what they're giving credit for. You'll see very often they'll say justify your answer or something like that. And they did, justify your answer. They're going to want to see that statement right there. Now, I might have reworded it in another way, but a lot of times that's a point right here. You've already seen it on problems 1, 2, and 3. They gave you a point for stating that a derivative was 0. Even if I think it was not part D of that ugly problem. So a lot of times they give you just don't know. So I would make that statement, and then I would say this occurs at x equals -2 and 2. Also, you could make an argument even on a closed interval that you throw out -6 because we're talking about a derivative there. Do you have a derivatives at endpoints? Can't do slopes at endpoints. So you could argue that that would not be true either way, but they bailed you out by just making you not have to worry about it by putting the open interval. Now it says determine whether G has a local max, local min, or neither. Okay, so what do you know about at -2?
It's neither.
At -2 right there, it just bounces off that. It has a positive, doesn't change sign, so that's got to be a neither. But at x equals +2, what do you know? Look at that, x equals +2. All right, the function goes from positive to negative of f, which means the derivative of g goes from positive to negative, and that the derivative of g is going from positive to negative at a critical number. What do you know? You're going to have a local or a relative max there. So make sure you state, if you made that statement right there, and that statement right there, you got the last 2 points. All right? So that's a 3-pointer, which I kind of felt was fairly straightforward unless you missed that connection in part B. And then part D says find all values of x on the open interval for which the graph of g has a point of inflection. Okay, so what do you know about points of inflection? They occur where what? Where the second derivative is 0 or dne and changes signs. Because if you just say 0 or dne, you're telling me what? It's not necessarily a point of inflection. It is a possible point of inflection. Yes?
Could you have said that when G prime goes from increasing to decreasing?
You can. Yeah.
I don't know why I said that, but I did.
No, it's true. Yeah.
For that +1?
Yeah, I say where it goes from positive, where G double prime goes from positive to negative, but that is the same thing. So you can say that, yes. They usually don't write that in their key, but they accept that stuff. So I wrote out, okay, if I know that already that G prime equals F, then G double prime equals F prime. So if I'm looking for where G double prime equals 0, I just make this statement. I say G double prime, which is F prime, equals 0 in D&E and changes signs. And where does it do that? So where does the slope of F change signs? Well, this is F, so the slope of F changes signs at what? -4, changes signs at -2, changes signs at 0, and that's it, right? Now, it exists, or D&E, slope doesn't exist, 0 doesn't exist, because that's technically a corner right there, right? So you have all, if it asks for the actual possible inflection points, they are, the X values of them at least would be -4, -2, 0, and 2. But you didn't get a sign change at 2, did you? So we're not going to count that. All right. So we're not going to count that +2 at all right there. So listing those and writing out what it actually meant or what made you come to those conclusions gave you those 3 points. So for some odd reason, they give you 2 points. I don't know how they divvied those up. 2/3, 2/3, 2/3. I don't know. But you got 2 points for writing those down. And then you got 1 point for stating why in your justification or your explanation. Y'all try? All right, so that's another 9 points. How are we doing so far?
Well,
I personally thought that the second half was easier than the first half. In the first half, remember, you had problems 1 and 2. 1, that area and volume, you're probably like, oh, sweet, area and volume, knock that out. Number 2, oh my gosh, for most people. Although I did see a couple of you guys did a great job on that number 2. But then they kind of rebounded on 3, 4, 5, and 6, I think. And I kind of forget 6. Let's see. It says, let F be a function with F of 2 equals -8, such that for every point on the graph of F, the slope is given by that expression. So that's the slope. So what is that 3x squared y? What is it?
The F prime function.
That's your F prime, right? That's your F prime of x is this. And they give you a point on the graph of F, right? So 2, -8. Now the question is, write an equation of the line tangent to F. See how often they ask this question? They're going to tangent line approximation. That's twice just in this free response section. At the point x equals 2, well, that's convenient. They gave me that point. And then use it to approximate 1.8. So what do you need to find a tangent line? A point and a slope. If you did this, it's very common, first practice test, people write this. Instead of writing -3/2, which is the slope you get when you plug 2 -8 into that, people put 3x squared y in there, right? And I'm sure anybody do that in here?
reason.
Yeah, people do it all the time. They put 3x squared y there, and then they're kind of stuck.
I use
When
a
it comes-
quadratic equation.
Yeah, I know. Yeah, chaos ensues, right?
Yeah.
So don't do that. Remember, you're never going to plug, or I can't say never, but I don't have a memory of plugging a variable expression in for slope. So if they give you the slope, remember, that's the formula. Plug the point in there and find your slope. And you got 1 point for just finding the slope, and then 1 point for either putting the equation like this or simplifying it into this. I rarely simplify those, but either way, you got a point if you did either of those correctly. And then the last thing you have to do is just use it. So I'm going to plug 1.8 in for that x and use this tangent line to approximate. So when I did that and cleaned it all up, you could see my answer ended up being -7.7. Yes?
Does it care if your answer's in a fraction? Like I have -77 tenths instead of.
No, totally fine. Totally fine. In fact, I think they take this or this. Well, they wouldn't take that because the 8's over here. But if you move the 8 over, you made it +8. There's a guy called, I think he calls himself something lame like Mr. Calculus. And he has this website, he puts stuff out, but he knows what he's doing. He's a little goofy, but he really knows what he's doing. And the second the AP test comes out, you can just look to Mr. Calculus. He posts the key before it, and like as soon as they release it, they don't release the answers because they like to give themselves the ability to go, oh crap, we didn't do that right. And then there'd be an uproar, right? But they released the questions. So he makes his version of the key and pops it out there. And we normally go and check what he says, although after a while you just see a trickle out of tons of different answers. Sometimes people differ in their opinions of what they are.
Is Dr. Calculus ever wrong?
Yes, occasionally. I got a workbook of his. It was like a couple hundred pages long that we bought to get some resources for early back in the day. And he had some stuff I was like, that's wrong. But most of it probably wasn't. It was probably careless errors. He's rarely conceptually wrong. He's pretty good. He's taught calculus for probably 30-something years. And I don't think he's even a doctor. He's just, I think he just calls himself Mr. or Doctor or something. But again, he's this bald-headed Mr. Magoo looking guy that's, but he does know what he's doing. But bottom line is he writes his answers unsimplified and has made many comments about it. He's probably been on the reading board, but he's made many comments about they don't care about the simplification. Now I do, again, because I'm always a little nervous about that. I just don't feel that comfortable. But a lot of his, he'll just put it to here and stop. Yeah.
Could you make it like unneedlessly complex? Like just start adding stuff. Like
I personally wouldn't do that because again, I know that the readers are in a hurry to get finished and they look at it and they're, to me, I would think the more simplified you have, the more easy you make it on them, the better it is. Because you know, if you're asked to do a task and you have to do that task quickly, you tend to make errors, you tend to miss stuff, and nobody's going to hold them accountable. Like they might make an error on your test, might cost you a 4 to a 5 or something like that. I don't want them to make that error, so I like to spoon feed it out very nice and easy for them. And our students typically do that. But yeah, 1.8, if that's bothering you, you know, change it to 18/10, you know, and then just start simplifying that way. It might be a little bit easier in ways, but whatever. That's up to you. Moving on, part B. Find an expression for y equals f of x by solving this differential equation with the initial condition. This is almost a 6-point question. In this case, it was 6 on every single AP test I have in memory. I've seen it as little as 3, but almost every year. And when I say almost, I mean, I might be able to think of one in the last 15 years that didn't give you either 5 or 6 points. And every single one, with the exception of this one, says if there's no C value, maximum points I can give you is 2. So if you forget to put that C in there, which makes sense, because what are you going to do? How are you going to work this in there and solve for C? If you don't put the C, they go, all right, max, no matter what, 2 out of 6. So when you're doing a differential equation, which you really need to make sure you know how to do, because it's one of those things like volume and area that is a gimme. You would know it's coming, and it's coming in abundance with a big question, right? Remember, separate your variables, multiply by y to move it up, multiply by dx to move it up. You get 1 point for separation of variables. Then when you integrate, 1 point for going y squared over 2, 3x cubed over 3. Now, it is very rare that they're going to give you something that simple and then give you a point for each integral and a point for the c. Very rare. They're normally, you're going to have a little bit trickier integral on one side. And when I say trickier, I mean maybe you have something like a 1 over y, so you got to pull out your log rule, or maybe you got to do a minor u substitution. Usually they're going to make you work a little bit for it, you know, but you got to put that plus c in there. Who had their hand up? Yeah.
If you just write x cubed instead of 3x.
Oh, sure. Absolutely. Yeah. I wrote that, but yeah, I probably wouldn't have written that. I probably wouldn't have written that had I done it. And then I'm going to multiply through by 2 to get to here. And at that point, I thought it would be a nice time to solve for my c, but I could have done it earlier. But remember this. Do you notice that when I multiplied through by 2, I didn't write 2c? Okay, so if I solve for c here, you can't put your answer there. Are you with me? We've talked about this before. If I solve for c with this equation, I can't put it in this one because my c value is changing as I simplify often, right? So if I decide to multiply through by 2, and I go, okay, here's where I'm going to plug in the point 2, -8. And by the way, you showed me, I showed you right here. Show that, all right? And they give you a point on this problem for making it obvious that you plugged in the point 2, -8. So I'm always going to write that. Sometimes they don't. In this one, they did. So literally, it said in the key, plugs in 2, -8, and I can see it. And the reason I like to do that is sometimes your formula is wrong, Like what if I accidentally had y cubed here and I plug in a -8 and I write -512, but I don't show my plug-in clearly. Well, they don't see that. They're like, I don't know what they plugged in. So I make it very clear to the reader what I'm doing. And when I do that, I simplify it and got C equals 48. Again, not plugging it up here. I'm plugging it here in the equation that I used. So I'm plugging that 48 there, bringing that down, and then I'm finishing up the solve. Now, last thing, why didn't I leave it plus or minus? Why did I choose minus? It can't be both, right? Remember on a differential equation, if I had a slope field, remember when I give you a point, you just start sketching through that point and it gives you a single equation, right? One thing, it's not going to give you two different equations. It's going to give you one equation when you sketch. That's what we're doing here. We're plugging a point into a differential equation that just happens to be solved. So what you have to do is make sure that point still works. If I plug the point 2, -8 in here, look, 2, -8, which sign makes this true? The negative one. That's why I keep the negative. So don't leave it as plus or minus, or you're going to lose that last point for that negative. And if there's not a negative situation, which very often there's not, those are the ones that are typically worth 5 points. Y'all seeing that? And that is the last 6 points of this question. So that's 27 points right there. 27 points is not going to help you pass, but even if you just blindly guessed on the free response, you're going to get law of averages, 11 of them, and 11 is going to give you what? 13 something points. You add 13 to that 27, you're at 40, you just passed. Not even counting, that's just blind guessing, not knowing what to do on the multiple choice and missing all of 1 through 3. So to me, a lot of times you'll see that a really harder couple problems and then some more doable problems. And if right now you're like, I thought all of them were brutal and I got hammered on this, it's okay, we got a month to go. A lot of more practice. All right. Yeah, I don't have anything for you to do now except try to study. I do want to go through the remaining calculator problems we didn't get to, and then we'll be done today. So if you want to jump to that calculator section, do you remember how far we got?
I thought we finished. Maybe it's the last two, but then you went over it like in the last minute of class.
Did we do that last one?
You didn't know, we didn't do it.
Did we get to the, oh, I didn't quite finish this number 91. So on 91, I thought it was a little ugly. It said, if f is a function and the integral from 0 to 8 of f of u du is 6, what is the value of this? So at first glance, I'm like, what? So I just said, you know what, I'm just going to go ahead and do this and see if I can change f of x squared minus 1 into f of u so I can use this model. But once again, this required a complete u substitution, right? So not only do I have to call that inner part u, and if that's u, then du is 2x dx. I got to put a 2 and a 1/2 to get the 2x dx, and that leaves me with 1/2 integral f of u du. But the mistake people make is they leave the 1 and the 3 in there. But remember, if I'm going to use this, I have to do a complete u substitution. It's kind of like that problem we did earlier on number 3 on the multiple choice, I think it was. So I've got to plug the 1 in for x, which gives me a 0, and I've got to plug the 3 in for x, which gives me an 8. And lo and behold, that's what I have. 0 to 8 f of u du. So if the 0 to 8 f of u du is 6, then I just have a half of 6. You seeing that? And that's twice on this test that has occurred. And it's always going to occur. When I say always, I have no memory of it not occurring at least once. But on this one, it happened twice. And if you didn't make that substitution, you're sitting here going, how am I supposed to know from 1 to 3? How do I use that? And I don't have an answer to that. So 92, it says the function f is defined for all x in the closed interval if f does not attain a max. Whoa. On a closed interval, f always has a max. Isn't that what the EBT says? No. There's another condition. On a closed interval that's continuous, it always has a max. Just because it's defined which means the domain exists, doesn't mean it's continuous. And I drew a picture of an example. This graph could jump and every value could still exist, right? So it's defined in the interval, but they didn't say it was continuous. So if it does not have a maximum value on there, then it must not be continuous, because that's the only condition of the EBT. Are you with me?
Thank you.
Okay, and this other stuff is just a bunch of junk.
If there was a vertical asymptote though, would it not be not continuous?
If there was, well, this one's not continuous, but a vertical asymptote would not be defined on X.
Oh, gotcha.
It would be undefined at that spot.
Gotcha, yeah.
So it would have to be something like the jump's the only thing I can come up with, because the hole wouldn't be defined. A VA wouldn't be defined, right? It would have to be something that was defined, but then hopped up and broke that continuity rule. But this is them checking your knowledge of the EBT. So you can't really get sloppy and go, oh, EBT says you always have a max or min. Evidently not. And why this is on the calculator section, I don't know. All right. How about that?
How about that?
I don't know if we've ever had 13 minutes left over.
I don't think we have. Been in here 3 years.
No, yeah, that hasn't occurred.
All right, awesome.
I try to maximize my 13 minutes. Anything y'all want to, hey, if I were you, I know it's a 25, well, actually it's a little bit bigger than that because it's going to be a larger section of that 50 points. So maybe 30-ish points. If I were you tonight, guys, you've gotten a preview of what the multiple choice looks like. I always feel like it's a little similar, although I got to be honest with you, this one we did might have been a little on the easy side, in my opinion. Sometimes there'll be like 2 or 3 questions you'll go, what on earth? But that's okay. Again, you don't have to make hundreds on these, right? If there are 44 questions total, if there are 45 questions total and you're getting 22 of them, 23 of them, you're probably in the 4 range. All right? You're getting 35 of them, you're in the 5 range. All right? You're getting 40 something, you're a monster, especially in April. Okay? So, but if I were you, I would go back and study the things that just yank easy points away, which are your derivatives of inverse trig functions. The integrals that result in inverse trig functions. Those are usually the ones that are not too hard to notice if you know the formula. Maybe study your theorem rules, just that packet. I would look over it and just maybe even make some flashcards of the stuff that you're struggling with, like the derivative of an inverse function, knowing that little rule. It's all in that packet. Know your unit circle. If you missed anything on the unit circle so far, go back and review those values. But that's what I would do at this point. Trying to study for these is kind of tricky. It's like studying for your AP English test. You've read the books or whatever, you know the English language, you're going to go in there and just do the best you can a lot of times. So I guess the studying is really just paying attention on days like this. All right. And then do your best not to miss these, because the problem with missing it is I got to go find you a different test. And if I find you a different test, then when we're going over it, you will just be kidding. I mean, you might learn something, but it won't be like, oh, yeah, I remember doing that problem. Oh, I did that. You'll really learn if you've labored through the problem, especially if it's unsuccessfully. You're going to go, oh, okay, I'm going to remember that. But if we're doing a different test than you, that's not going to be great. Somebody told me they were going to miss Thursday, but now they're here. Is that anybody in here? When you? Okay. Anybody missing Friday or Monday? Okay.
No, never had this part.
Okay. So we're all good. Good. Try to be here. And again, we're going to go over these. And then I'm going to give you the multiple choice parts. I'm going to do that right there. Might just give you the multiple choice parts right now. And if you want to play around with those, these are the ones you're going to have for homework, the 2 nights we're testing. So I'm going to give you Thursday and Monday's homework right now, and then you can just have these ready. You really have a little bit of time to work on them, because I'll probably go over multiple choice, then free response. You know, just kind of do it as we get time over the next, over the following week. So here are the 6 free response questions that we'll be doing, and we'll just be going over But hopefully after doing these, you'll really start seeing kind of the style and what you're gonna need to be, how you're gonna need to be writing stuff. If you're wondering why I'm stapling like this is how you receive it from them. It's kind of bound up. So you're opening it up like a book. So I'm trying to simulate.
Are we gonna get in trouble if we remove the staples on the test?
I don't think so because, well, actually, don't do that because it's not like this. There's our long sheets of paper that are bound in the middle, like a booklet. It's like a booklet.
Oh, that's better.
Yeah, theirs doesn't look like this. On mine, you're welcome to remove the staples, but I think it's really nice to literally, if you just open it up like this and fold it, then you can see all of problem one nice and neatly. That was really my intent, right? Because if it's stapled at a corner, when you open it up, you're looking at this. But this makes it really easy to see everything. So that was my hope. Well, all right. Enjoy your free time. It's down to 8 minutes, so I feel a little less wasteful.
Tomorrow is the calculator work.
Non-calculator. The way it works on the AP test is you usually do non-calculator, multiple choice, calculator, multiple choice, and then calculator for your response,
You're ready.
non-calculator. So they put the two calculator sections in the middle.
Okay. It says calculator. What?
Do what?
It says calculator. No, we didn't. She better give us contact. So,
Hey, I said calculator on there, but I don't care which one we do first. You pick when we come in here. I got them both.
oh, so you weren't on Google Meet?
I tell you what, hey, we're just gonna stick to the thing. The thing said calculator,
Go with calculator.
we're going with calculator.
We could just use calculator on this. I'm actually using calculator. Graphing